So this is your topic or title of your course, that is 3D printing and design. So as you already know, but I will just revise it. So today's lecture will be organized like this, or it is organized like this: introduction to 3D printing processes and definition of the 3D printing process, overview of various 3D printing processes and application of 3D printing process, especially in automobiles. The 3D printing process comes under one of the manufacturing process. Of course, it is a very latest one, but it can be classified under manufacturing processes. Earlier, basically, there are two manufacturing process we used to use it. That is a subtractive manufacturing process and formative manufacturing process. In a subtractive process, what we do is we take the raw material and we remove the unwanted material with the help of a specially designed cutting tool. Then we get a required shape. Okay, so that is one of the manufacturing process we call as a subtractive, and mostly we call as a machining process. And whereas another manufacturing process is also there, where we heat the workpiece and convert into the required shape between the dies. So this is a lower die and this is the upper die. And the die cavity, this is a cavity here in the upper part and this is the cavity in the lower part. So we place the raw material within these two and we apply the forces. You can see the arrow marks here. So with the help of these forces, the raw material will be deformed into required shape like this. Okay, in the both the cases you can see the output is same. Output is same. So these are the two different manufacturing process. Earlier people used to use it, but now there is another manufacturing process as introduced around 10 to 15 years back, and people are now using very frequently. That is we call as additive manufacturing or 3D printing process. In a additive manufacturing or a 3D printing process, neither we remove the material nor we change the shape. What we do is we add the material layer by layer until we get the required shape. That means here you can see, if you want this particular shape, I will add first layer like this, and the second layer like this, and the third layer like this, and fourth layer, and fifth layer, and sixth layer like this. So finally, we are going to get the desired workpiece shape using additive manufacturing or 3D printing process. So that is our today's topic, that is 3D printing process and design. So before going to 3D printing process, why it is named as a 3D printing? So there is a small background is there with the concept of 2D printing. So what we do in a 3D printing, in a 2D printing, so mostly the examples are your laser printers or inkjet printers. We prepare a soft copy using Word document or a PPT, etc. And if you want to print it, okay, we use 2D printers like laser printers or inkjet printers, where the printing of a letters will takes place in a two directions. Let us assume this is X and this is Y. So that's why it is called as a 2D printers. 2D printers. So if you want a 2D printers, we require a soft copy in either Word, MS Word, or any PPT or any soft copy which is available in the two-dimensional form. Then that you can print it on a paper, so that we call as 2D printers. But now we are shifted, or we required a 3D printing components, so where we can visualize three-dimensional components. So if you want a 3D printing, we require a 3D printers, but if you want a 3D printers, we require a 3D modeling. You can see here, the left side is a 3D model. Left side is a 3D model. Okay, this 3D model, we can model it in CAD softwares like AutoCAD basically, and Creo, CATIA. There are so many softwares are there. Using those softwares, we can design a component like this. And the same component using a 3D printers. You can see here, this is a 3D printer, especially we call as FDM, Fused Deposition Modeling. Fused Deposition Modeling. Using this machine, we can print the work piece layer by layer until we get the required shape. So that is digital to physical. Digital is a soft copy in the form of 3D models, and physical is the output, that is hard copy, the model, that is a hard 3D printed component or physical component. So that's why it is called as a 3D printing. We are printing two-dimensional layers, but those two-dimensional layers we are building layer by layer, one over another, until we get the desired height and desired profile. So that's why it is called as 3D printing. So now let us define the definition of a 3D printers. So earlier people, okay, different scientists or researchers have given different definitions. So the first definition is a technology that produces models and prototypes from the 3D CAD files or CT and MRI scans in the case of medical applications, or the model created from the 3D objects, that is reverse engineering. Very simply, the 3D printing process is defined like this. A model is printed, the physical part is printed either from 3D CAD model data, that is the soft copies which are available from any CAD softwares, or the soft copies which we are generated from the patient's data like CT scans, MRI scans, or if the soft copies are not available, for example, very old model, and the designs are not available, so and it is difficult to draw, and difficult to measure the dimensions. In that case, what we do is we do reverse engineering. That means we scan the object using 3D scanners. So using those 3D scanners, if you scan the particular object, and the 3D scanners will convert the that particular physical model into 3D soft copy model, and from that you can reproduce the number of components. So that is a simple definition by Terry Hollers, and Joy also given his own definition, that is digital fabrication of the parts, components or models from 3D CAD drawings without part specification or part specific tool or human intervention. So earlier we have seen two different manufacturing process, that is machining process or subtractive process and formative process. In those two cases, we require machines and the specific tools. That is, in the case of formative, we required a die, and in the case of machining process, we required cutting tools, machine tools, etc. But here, except a 3D printing machine, we required any special tools to produce 3D printed components. So these are the two definitions, but later on ASTM is involved, that is a standard organizations we call as you know, American Society for Testing of Materials, and this organization has given the final and systematic definition, and that is the process of joining the materials to make the objects from the 3D models or a 3D model data, usually layer upon layer, as opposition to subtractive manufacturing methodologies such as traditional machining process. That means the ASTM has defined a definition for 3D printing, where the process of joining the materials to make the objects from the 3D CAD models by layer by layer joining or addition. So that is the different definitions given by the different people or different organizations. So any definitions is acceptable. Okay, but the 3D printing or additive manufacturing, both are same. And along with these two, there are other synonyms people will use, that is additive manufacturing, additive process, additive technique, additive layer manufacturing, and free form fabrication. So these are the different synonyms for the additive manufacturing or 3D printing process. So what is this 3D printing process? Already we have defined 3D printing process. So here you can see the soft copy we have prepared using a CAD system, and from that CAD system the soft copy of a 3D model is transferred into a 3D printing machine, and where the 3D printer will produce the component. But if you see, 3D printing machine is a manufacturing process in which the functional parts can be made by adding the materials without specific tools, jigs, and fixtures. Whereas in all other manufacturing process, we require a special tools, jigs, and fixtures to hold the workpiece or tools. But in this case, we do not require any special tools. If we have an exclusive 3D printer machine, you can able to produce any shape, any component. It provides a tremendous advantages as compared to the traditional substrate to manufacturing process, such as the shorter lead times. That is a one important advantage. Less wastage. The material is consumed systematically, and ability to make more complex parts. That's what you can see here. This is a part. This part, if you want to produce any conventional manufacturing, it is not possible. Possible. So that's why any complex parts we can able to make it using 3D printing process, and cost dependent. So the complexity in the case of other manufacturing process, if the complexity increases, the manufacturing cost increases. But here the cost not much increases. Only the time of machining or time of producing the component may increase, but the cost much depend upon the complexity. Okay, so additive manufacturing is a fabrication of a complex free-form solid object directly from the computer models of an object without part-specific tooling or knowledge. So here much knowledge is also not required about the process, only the knowledge of the 3D printing and the conversion of a 3D model into the machine. If that knowledge is there, and then we can able to produce any component. So earlier, these models, the 3D printed models, earlier we used to call as a rapid prototyping or a prototyping. So what is the role of a 3D printers or a 3D printed components? The role of prototypes or components plays a very significant role in the product development process, and they are experimentation and the learning. That means you can produce one component using that, and you can do the experimentation, and you can also learn during the experimentation how it is reacting and how it is performing, etc. That's what we can say, that testing and proofing. That means we have to test that. We can test the first single component, and if everything is okay, then we can go for mass production. And not only that, the 3D printed components, we can use it for communication purpose and the demonstration purpose and the interaction with the outside people. So suppose a new concept is there, and the new concept, if you want to explain to others, so this is the best way of communication using 3D printed components, and we can easily interact with the outside world. So these are the roles of a prototypes or a 3D printed components. Why we need to go for a 3D printing process? So the 3D printing process produces very quality components, and we can increase the productivity, and it reduces the cost if you go for mass production, and reduce the costly errors, because in other process, once the manufacturing is over, and if you measure the dimensions, or if you check the errors, or if you check for quality, so after the manufacturing, if you check it, and if already process is done, and if you are doing now, and already the damage is done, but you are doing at the end, so that is not there. And you can see here simulation before producing. You can do the simulation, and if the simulation works well, you can go for actual production, so that the costly errors we can reduce it, and the customer satisfaction takes place, because as per the customer design. So suppose an engineer has designed the component, but you can take the opinion of the customer whether it is okay or if any modifications are there. So if the customer suggests any small modifications in the design or the model, you can easily implement so that as per the customer design, you can produce it so that finally the customer will satisfy. And in the present days, the 3D printing is a global competition is there because n number of printers, n number of manufacturing processes are there. So whoever produces the component fastly to the market, so he can take more market, and he can produce a lot of profits to his organization. So that's a global competition is there because we need to produce a component on time to the market. Okay, if the competitor, if a company is have a competitor, if you produce a component much earlier than your competitor, so you will be in the market. So that is possible using a 3D printing process. And finally, we are going to produce a product, or we are going to develop a new product using this 3D printing process. So if you want to produce a 3D printing process, if you want to produce a component using a 3D printing process, there are several steps are there. Okay, the first step is production of the CAD model using softwares. And then that model, mostly every software will have its own domain of saving. If you say AutoCAD.wg, and if you take Creo.prt, like that. So those models you cannot directly transfer into, those files you cannot directly transfer into 3D printable machines. We need to convert into .stl file. So .stl means stereolithography or standard tessellation language. That is a full form people used to use. Okay, so that file conversion we need to do it, and then we need to slice the component into n number of layers. Once the first layer is built up, and then we can go on build up the next layers by lowering the platform where we are taking the base for the first layer. And then once the material is our model is printed, we have to remove the supports, and we need to go for finishing and clean. So these are the 4 important steps. Okay, and the same thing you can see here. So this is the first step, CAD model preparation. And here, before printing, we need to convert into .stl file. That's what I told earlier. And before printing, we need to give the supports to the model. And after giving the supports, we need to give this slicing, how many layers we required, how many layers by which you need to produce the components. So those things, those data we need to give it. Once the data is given, okay, the file will be transferred to the machine, and the machine will produce the component by layer, you can see here. And once the component is produced, we have to clean it by removing the supports, and we need to go for finishing if it is required. And if it required post processing, that is if you want to increase the strength and other properties, we need to go for a curing process. So these are the steps involved in 3D printing process. And the 3D printing process basically classified into 3 types. One is liquid based 3D printing process, powder based, and solid based. And this classification is given by Hopkinson and Deacon's classification. So under that, each classification or each method, there are different processes are there. You can see here stereolithography, jetting, digital lighting process. Similarly, powder-based 3D printing process mostly used are selective laser sintering process and laser beam process, 3-dimensional printing process mostly used powder based. And the last one is solid based. There are 2 processes mostly we use it, that is fused deposition modeling and sheet staking technology, that is also called as laminated object manufacturing process. So these are the different 3D printing process classified into liquid, powder, and solid based manufacturing. And this, okay, there are so many processes are there. So to avoid confusion to the customer or the manufacturer, uh, as I said earlier, ASTM, American Standard for Testing of Materials, has consolidated all those process into 7 additive manufacturing process as per F2792. That is a standard number as per ASTM organization. So finally, the additive manufacturing processes are classified into 7 manufacturing process. The first one is binder jetting process, and the second one is direct energy deposition process. Third one is material extrusion, people also called as FDM machines, material jetting, powder bed fusion process, sheet lamination, VAT photopolymerization. So if you see for this we call as another name stereolithography, stereolithography, and we call as SLA, and is for sheet lamination, laminated object manufacturing, and most used powder bed fusion process is SLS, stereolithography, and for material extrusion process FDM. So these are the general names for day-to-day applications people used to use, but these are the standardized names as per ASTM process. Now we'll see all these process, their working principles and materials used, applications, etc. in the next slides. And this is in a rapid prototyping or 3D printing wheel we call. And this wheel is divided into 4 sectors. And the first sector is input. So the input we required is a CAD model and conversion into STL file and slicing that model into n number of layers. If the data you can with the data you can convert into CAD model. Sometimes what happened, as I told, the component profile and the dimensions you cannot build using a 3D print 3D CAD software. So in that case we use a scanners, and from the scanners we will convert into CAD models, and then we go for printing. And the next one is, after model is ready, which process you are going to use it. There are, okay, as I said now, 7 process as per ASTM. So once the process is chosen, and then the next step is material selection. So based on the process, there are different materials are available for each and every process. So once the material and the process is chosen, and then we can print it, and those printed components we can use it in the different industries like aerospace, automotive, biomedical, consumer products, etc. So there is, okay, these 4 steps included in the form of a wheel, and that we call as a 3D printing wheel or additive manufacturing wheel. So what are the advantages of 3D printing process? So precisely, the direct benefits are benefit to the product designer, because whatever the product he is going to design, he can test it. He can test it very quickly and easily. And a very old, okay, in olden days, okay, once the product design is there, and then he has to produce one component with the metal or with some other materials, and then he has to do testing, and producing it and testing it will take more time. But here, in using a 3D printing process, you can able to produce the component and you can able to do testing very quickly. And not only that, the 3D printed components, we can use it for tooling, and tooling that you can able to produce some tools directly, and you can produce it some dies. Okay, these are useful for manufacturing engineers. So the 3D printing process is mostly directly useful to a manufacturing engineers. And indirect benefits are benefit to the market, because you can able to bring the component to the market very quickly. And not only that, as per the customer requirement, you can modify and you can able to produce components very quickly, so that the customer can satisfy very quickly and easily. So these are the indirect and direct benefits of a 3D printing process. So now we'll discuss the 7 processes of 3D printing or additive manufacturing process, about their process, strengths, and the material which we are going to use for those processes. The first one is liquid based manufacturing process that we call as VAT photopolymerization. Okay, VAT means a bin in which we place a liquid material, and the liquid material layer by layer will be scanned, and that during the scanning, the with the help of chemical reactions or polymerization process, wherever the liquid material is scanned with the laser, that will be solidified. And once the first layer is solidified, the platform will be lowered or moved down, so that the liquid which is surrounded will come over the first layer, so that the second layer is ready to solidify. So like that, the process will be takes place by moving the platform downwards, so that layer by layer manufacturing will takes place from liquid to solidification process with the help of photopolymerization. So once the solid component is completed, our entire component is built, and we take it out and we go for removal of supporting materials or finishing process. Okay, what are the main advantages of this process? The advantages are high strength component you can able to produce, and not only that, complex properties also, complex components also you can able to produce it. Smooth surface finish. Okay, accommodate large build area, that means larger component sizes also you can able to produce it. And mostly here we use plastic components, because we can convert that plastic into liquid stage very easily. So that's why mostly we use UV curable photopolymer resins in this process. And the next process is powder bed fusion. So these are the different techniques under powder bed fusion process. The first one is selective laser sintering process, and the second one is a direct metal laser sintering process, selective laser melting, electron beam melting, selective heat sintering, and multi-jet fusion. That means you can able to print here multi-material. So let us take first the selective laser sintering. So here we take the raw material again in the bin only, and the bin, okay, the bin consisting of a platform, and the platform can move up and down. So here the first layer of the and the first layer, the powder is spread with the help of a roller onto the platform, and that powder is scanned with the UV light or laser beam, and wherever the light is exposed or contacted with the powder, and that area will be melted and solidified quickly with the help of heat transfer. Heat transfer. Once that first layer is built up, okay, the platform will be lowered down, and the next layer of powder will be spreaded onto the previous layer or a first layer with the help of a roller, so that the second layer also will be scanned with the laser beam or electron beam, and the second layer also built with the help of laser, that is melting and solidification takes place. So like that, the layer by layer will takes place in powder bed fusion. So that's why it is called as a powder, and this comes under powder based 3D printing manufacturing process. Here the strength of this manufacturing process or 3D printing process are high level of complexity components you can produce it. Powder, the surrounded powder you can see here, this powder, and here it will act as a supporting material, so there is no need of taking another supporting separately, and a wide range of materials you can print using different materials you can print the components. So that is the main advantage of this process. And the typical materials starts from the plastics, because the plastic we can get it in the form of a powders, metals, ceramic powders, and sand. So this is about the powder bed fusion. Mostly used is selective laser sintering process. And the next one is the binder jetting process. The name itself is a binder jetting. So here also the raw material we take it in the form of a powder only. But instead of melting and solidifying, here we deposit binding materials. So those binding materials will react with the powder, and wherever it is deposit, and that area it will be reacted with powder, and that area will be solidified with the help of the binders, with the help of a binder. So here we are sprinkling or spreading our the metal binders, sorry, not metal, binding materials. So that's why it is called as a material jet, binder jetting. Binder jetting. We are depositing a binders onto the powder layers, and wherever the powder binder is depositing, and that area will be solidified, and the next layer of powder will be spreaded onto the previous layer. So like that, wherever you required, and that areas only the binder material will be deposited, and then it will be solidified and it will be produced in the form of a three-dimensional components. So here allows full color printing. So whatever the colors, that's what you can see here, because the binder will have, okay, the binder can be have a different nozzles, and with the help of the different nozzles, if you can give the dyes or different colors to that binders, so you can able to produce a different color printed components, high productivity, and again a wide range of materials you can able to print it. And again here, the typical materials we can use it as similar to the powder bed, plastic powders, metal, ceramic, glass, and sand powders also we can use it. And the next one is material jetting process. What is this material jetting process? It's almost, okay, similar to binder jetting. Okay, but here you can see, instead of depositing binder material, here we deposit powders. So here we kept the powder in the bin, but here there is no bin. We just have a platform on which we sprinkle or we deposit a powder. But once the layer of powder is depositing from left to right or right to left, immediately you can see here a laser beam, or UV light beam is there, and that UV light produces a heat onto the powder, and due to that heat it starts melting and solidifies onto the platform in as the laser beam moves along with the powder deposition. So that's why it is called as a material jetting. Material will be deposited on the platform in the small particles, and immediately that deposited material will be scanned or exposed with the heat by in terms of UV light, so that powder will be melted and converted into the solidification with the help of surrounding airs or a cooling air which is surrounded there, and then it will be solidified under the ambient process. The strength is again high level of accuracy you will get, allows for full color printing. That's what you can see here. Here also, here we are depositing different colors of binders, and here you can deposit or spray different colors of the powder, so that you can get the different colored product, and enables the multi metals in a single pot. That means you can able to produce the different materials on a single component, and the typical materials are photopolymers and the polymers and waxes we are going to use under this process, not metals. Soft materials like polymers, plastics, and waxes we are going to use under this process. Are you able to hear me? Hello?
Yes, sir.
Okay.
Yes, sir.
So, okay, thank you. So these are about first four process. Okay, first one is a liquid based, and this one is powder based, and these two comes under again liquid based 3D printing process. And as per your syllabus, these are under unit number one, and this is unit number 2, and this is unit number 3. And now we'll go to another manufacturing 3D printing process is sheet lamination. And you can see here there are two rollers are there. On these two rollers, the sheet is wounded, or a sheet is kept in the form of a rollers or in the form of a reels. And the first layer of this raw material is moved and placed onto a platform, and then that first layer is exposed and with the laser beam, again a laser beam or UV light, and wherever those areas, you can see here in the middle air, this is the diameter of that sphere, and here this is the diameter. So wherever you want to project that laser beam, that you can control with the help of a 3D printing machine. And once it is exposed, and then that area will be cut because that is exposed with the light source, and that will be melted. And once melted, and the material will be cut into that particular, that means if I show here, so this is the sheet, and the laser beam is moved like this. So this area of the sheet is cut and separated from the raw material. So once it is separated, and then the platform will be moved down, and again the next layer of raw material will become onto this platform, and the older layer will move on to the used reel here. And when the next layer comes, so along with the moving onto the platform, and this material also consisting of a binder. Okay, binders or adhesives or chemicals are spreaded onto the sheet, So what happens when this first layer is built and the second layer is coming onto the first layer? So due to that adhesive which is there to the sheet, will bonding will takes place with the help of the heat which is generating with the help of the laser, as well as the second layer will be cutting takes place during the second step. So like that, the process will be continued until the entire model is produced. So that's why it is called as a sheet lamination. In the lamination also, what we do, we place the paper in between the plastic sheets, and then we apply the heat so that the lamination will takes place. So here also the same thing. The layer by layer adhesion will takes place with the help of adhesives which are placed between the layers, or sometimes we can use some ultrasonic welding or brazing process also we can apply it. Okay, so this process tends are high volumetric rates and the relatively low cost, and allows for combination of the metals. And mostly here the material should have in the form of plastics, paper, and the metals in the form of a foils or the tapes. And the next one is very frequently used and the low cost machine is material extrusion, and this we call as a fused deposition model. And here you can see there are two reels are there again, and one reel is for supporting material, that is the wire. Here the raw material is available in the form of a wire. Okay, and that wire is passed through a nozzle, and the nozzle consisting of a heat source, and with that heat source, the whatever this wire which is feeding through nozzles will be melted, and the melted molten metal will be deposited on the platform. Okay, so once it is deposited, at the same time the supporting layer also will be deposited to give the support wherever the overhangings are there or support is required. So two materials, one is for supporting, another is for actual material or a component material. So here also again, once the first layer is built, the platform will be lowered down, and so that the second layer will be built. So again the layer by layer building takes place, but here the raw material is in the form of a wire. So wire is extruded through nozzles or a heated nozzles or a heating nozzle. So that's why it is called as a material extrusion process. So this process is very economical and inexpensive. And here also you can use multiple colors, and you can use it in the, okay, it is available in the form of a desktop printers. That means you can print it just like in office laser printers. These are also, you can use it as a office printers and have a good structural properties. And here mostly we use it, okay, liquids, slurries, thermoplastic, filaments, pallets, etc. And the next one is, this is not there in our syllabus, but you can just have a look on this. That is direct energy deposition. Okay, so the other names are the other varieties under this are laser metal deposition, laser engineered net shaping, and direct metal deposition. Let us discuss the first one, that is direct energy deposition. So here you can see a blade. Let us assume this is a turbine blade. And if you want to produce a turbine blade, again, we use here a platform on which, okay, the layer by layer manufacturing takes place. But you can see here a nozzle is there, and the nozzle is connected with the hopper where, okay, it is consisting of a 2 or 3 chambers. Let us divide it into this one into 3 chambers. So here the raw material is available in the form of a powder form, and here a heat source, that is a laser beam. So due to the gravity or due to some other source, we deposit the powder particles here, and the laser beam is also coming out. And when the powder is deposited on the layer, and that is connected with the laser beam, and due to that laser high, the powder particles will be melted, and the molten metal will be, okay, spreaded onto flat form in a particular direction. So immediately it will be solidified. Okay, so once the first layer is built up, the second layer of uh, powder along with the laser beam will be traced or moved onto the first layer. So the second layer also built up until the process will be continued until all the layers are built to get a 3D model. But here, if you are using a laser beam, then it is called as laser metal deposition. And there are some different processes are there, that is laser engineered net shaping and direct metal deposition. So only the difference is, okay, in the laser engineered net shaping, okay, so here we are using in the direct metal deposition. In the direct metal deposition, we can use the heat source maybe from gases. So that is, if you are using a gases, then it becomes a direct energy deposition. And if you are using laser, and then becomes laser metal deposition. Okay. So the strength of this manufacturing process are, or 3D printing process are, not limited by the direction or the axis, whereas other process will have access limitation because the powder and the bed will move downwards only. But here also the bed is moving downwards only, but the projection of that raw material and the heat source you can control in a different axis. Effective for the repairs and adding features. Mostly this process is used for repairing of the costly components, like wear and tear is taking place in the costly components, and if you want to regain its own initial dimensions, so this process mostly we use it. And multiple colors in a single component, highest single point deposition rate, that means the productivity is more. And here the metals which we use are metal wires, powder, or ceramics also we can use it. So that is about direct energy deposition method. And the last one is, this also not there, but I will just inform to you, hybrid manufacturing process. Hybrid manufacturing process means one side we will build the component with the help of a 3D printing process. Another side, okay, wherever unnecessary parts are there or overhangings are there, we do the machining using CNC on the same location. That means, okay, one side we do the machining process, another side we do printing. That means, otherwise also, once the component is printed onto the machine, and using the same machine, we use machining process also, so that we'll get the both manufacturing as well as final finished component, so that we need not to go to another machine separately. So that's why it is called as hybrid manufacturing, combination of printing as well as machining process. If it is there, that capability is there to the machine, and that we call as hybrid manufacturing process. So that's about the 7+1, that is hybrid manufacturing, different additive manufacturing process. So I just said a 3D printing process consisting of several steps. So just now we discussed about the process, but how the process will takes place in different steps we'll see now. First, we required a 3D modeling, and that 3D model we need to convert into STL file format. Okay, and then after converting, we have to check and we have to prepare it whether entire model as uniformly converted into a triangulation language, and if anything missed, okay, we have to verify it. Once the verification is there, then we have to place it onto a machine. That means we have to transfer that model into machine platform. Once it is transferred, automatically the 3D printer will print the components. Once the printing is over, we need to go for post processing, like removal of supporting and the finishing of that component using a finishing method, so that the final component is ready to use it. So these are the 4 to 5 steps are there in 3D printing process, and those process is a continuous process. That's why it is called as a chain. You can see that this is a first step. We require the model, and then the model we need to convert into the STL file, and then we have to slice into a number of layers. And so once the slicing is over, then we can able to do printing. So the same thing we can, if we are here, we represent it in the form of pictures. So first we are going to model the component using a computer, that is a 3D softwares, and then we convert into STL file, that is a tessellation of the uh, component, that is STL file, and then we slice this into a number of layers, and then using the RP machine we produce the components, and after producing the components we finish it with the help of post processing processes like polishing, trimming, etc. Once the prototype is okay, we use it for final usage. Otherwise, if any drawbacks are there, we will remodel it. So the process will be continued. So that's why it is called as a 3D printing and a chain. The same thing is here. So now we'll see some of the machines, how it looks like and other things. So this is FDM machine, FDM machines, and you can see here, okay, this is a high volume FDM, and this is a desktop model. And you can see here, these are the reels through which wire form material passed through a nozzles, and here this is a build platform. Through on this, we are going to build the component. The most common technology in the desktop models are most commonly used. Okay, you can see here the best, okay, innovative example, that is a chocolate is printing with the help of this method as per the customer requirement. And next you can see here material jetting process. Material jetting process, here the powder is deposited onto build a platform, and simultaneously the laser scanning with the laser or UV light in order to convert that powder material into a solid form. So this is a larger version or a high volume. This is a smaller scale material jetting machine, and this is a binder jetting machine, mostly used for, you can see here, okay, mostly used for making of a prototypes or what we call patterns for investment castings and visual prototypes, and we can make some tools also. And you can see here sheet lamination. Okay, reels of a paper act as a base material, and but the disadvantage is a low strength. Okay, opportunities, that means here you can do some research to increase the resolution for the color, and resolution increase the accuracy of the component. And this is a VAT polymerization, also called as stereolithography, oldest 3D printing technology. And you can see this is a machine, and you can see here some of the components are building up using this technique. And this is a powder based systems, that is SLS, and a wide range of materials we can use it, very high strength functional parts. You can see here, okay, shoe with the spikes, that is a sports shoes. You can build it as per the uh, customer dimensions we can build it. And the base metal is a powder form. And this is a machine of that selective laser machines, and this process already explained. And these are some of the process parameters which, okay, if anybody wants to do research on this selective laser sintering, okay, you can change or we can vary these parameters like laser power, spot size, hatching spacing, beam speed, vector length, etc. So that we'll get a particular strength component. And if you vary it and whichever the suppose if you are produced by varying these parameters, and after that if you measure its quality characteristics and which under which parameters you are getting a good strength component, okay, and that you can finalize it for a mass production. Okay, so where we use this SLS, mostly we use it for conceptualization, packing purpose, presentation purpose, and the prototypes for design, analysis, verification of the functional parts, and prototypes for tooling, that is dies we can able to produce, low volume production tooling, and the patterns for the castings, and the tools for the jigs and fixtures. Okay, so if anybody interested, you can do research on improving the accuracy and the speeding of the, that is mass production, and developing of new tools, new materials and advanced materials, and direct energy deposition. So that's what I told here, electron beam if you're using, okay, and laser beam also you can use it, so that we can able to produce the component from the powder form to solid 3D component. And here mostly we use it for medical application and aerospace applications and the repairing purpose. And you can see here a skull. So okay, suppose and if any accident a skull is damaged, and the damaged part we can replace it with the biocompatible material here, and we can print it and we can replace at that location. And this is another variation with direct energy deposition. So here, if you're using electron beam as a resource, a heating source, then it is called as a direct energy deposition. And if you are using a laser beam, then we call it as a laser engineered net shaping. Okay, here you can see a laser beam at middle or inner orifice and surrounded by two powder delivery channels. So the powder is coming from here, it is depositing over here. At the same time, the laser beam is focusing at this location. So that laser beam will melt that location. And as the laser beam is moving to other directions, the molten metal which is there at that location will be solidified. Okay, so the principle already told, and but some of the important things are, it is also a laser by laser, and high energy from laser beam creates a puddle on the surface. That puddle means a liquid form, and the powder is deposited onto the puddle form to form a bead, and the bead is controlled to form a solid layer. Okay, so here the research, you can, if you are interested, you can do the deposition rates. That means how you can control the deposition rate to get the quality products. And thermal conductivity you can do. Okay, that means working on the thermal conductivity materials and developing a software to handle the part that require the support structures. That means the support structure is a little critical here. Okay, the support structure you can, okay, to minimize the material consumption for the supporting structure. So this is a 3D printers. So in a 3D printers, we again use a powder only, but the binding is we are using, okay, binding agents we use instead of a laser beam. Instead of a laser beam, we use here binders to add the powders together and with the previous layer. Okay, so this is, you know, first step, we disperse or we spread the powder onto the platform, and then once the depositing is over, and then the binder material will be deposited. Once the binder material is depositing, the joining of the powder together will takes place. The freezing, okay, fusing of powder takes place, so that the entire layer will be converted into a solid form. Once that is over, the next layer of the powder will be spreaded onto the previous layer, and the process will be continued until we will get a required product. The same thing I have explained. So let us see, as per the 2012 market survey, as per this Hollers Associates, Ronald Beggar. Okay, AM applications have been developed in the various industries, and you can see the market share 370 million euros in the consumer products or electronic goods, and similarly for automotive 320, medical 380, and others 330, and tools and manufacturing 230, and in aerospace applications 180 million euros. The market is there with the help of this 3D printing. And now we'll see some design aspects of this 3D printing. You can see this we call as a topology optimization. So earlier in the conventional manufacturing, people used to use the modeling and the printing manufacturing with the help of this design. But now you can see the material consumption is less with the help of this particular design, as well as the aesthetic point of view is improving without compromising the strength. So that is very, very important. And now we can see this is the initial way of producing the profile of the component like this. But using a 3D printing, the migration has been taken place to get a profile like this from this profile. So now you can see how much material we have saved without compromising the strength. In fact, the strength and other things are also improved. And you can see some more designs. So you can see here, okay, pedal of an automobile, and this is some other component just like a shoes, and this is one more mechanical component. Okay, and you can see some other examples of how the topology is optimized. Okay, you can see here, okay, a seat, okay, of an automobile car, and you can see the in details, and you can see some extra fittings or extra arrangements so that okay, the operator, the driver feels comfortably without getting any back pains, if even though if you go for long drives. And you can see here Archer's instrument are above, so that is also, you can see earlier this is entirely a solid material. Now it is meshed, okay, meshed in the meshed form, so that the weight is increased, so that it can target is a point very easily because of less weight. And you can see here it is not only belongs to mechanical or electronics in the fashion point of view. Okay, so this is a 3D printed gown or shirt, whatever you call. So not only in the mechanical and other engineering applications, fashion applications, also the 3D printed components we are using. And in the civil applications, you can see directly we are building a house here, and already we have seen a chocolate, okay, using a 3D printing machines. And you can see here 3D printed seat, okay, for disabled persons. And you can see design freedom. That means you can see here, earlier if you want to print out this type, it's not possible because this type of pattern of holes making, and you can see here some, okay, designs are there. So this is not possible, even though if you take it plastics, and the hollow portions are not possible. And if you want this type of hollow portion using plastic printing, the dies are very, very costly, and it is not possible. Okay, so in that case, the 3D printers are very useful, and you can see here a shoe also you can comfortably printed using 3D printing. And the geometry freedom, you can see here the peripherals. You can see here, okay, whatever the design you want, that is aesthetic point of view are good looking, and those we can print it. And now you can see here the cell phone covers are chain. You can see here, okay, so the volume consumption is reduced using this one. But still some challenges are there using with that means some research you can do it, that is limited and high cost of the materials. What are the powders we are using for the materials, that metal materials are high costly, and still there is a rejection of 20% due to some drawbacks and the challenges in the scaling up of the technology. That means now we are using only for the limited materials, but not all the materials are suitable. Not only that, dimensions are also restricted, and the speed are relatively less now, and some environmental issues are there. You can concentrate on that. Surface finish you can improve. That means improvement of the surface finish point of view also you can concentrate, and the resolution, that means strength point of view and the density point of view you can concentrate further research, and the mechanical properties improvement also you can do. And the post processing is a challenging, and still only we are making a prototypes in the most of the cases, but still actual products if you want to produce, so we need to do some research scope is there with the help of this 3D printing. Okay, now just I will concentrate related to the automobile applications. Okay, automobile, you can see here in automobile, these are the components, door handles we can able to produce using 3D printing, FDM process especially. So you can see most of the process are FDM processes only. Okay, car air vents, shifting knob, that is gear shifters, and wheel seats are also can be produced from the 3D printing. And you can see here this is in a four different models. Okay, and they are produced for demonstration purpose or visualization purpose of those different models using a 3D printing technologies. And Forge has produced 3D printable sheets, and now they are using these techniques to produce sheets of their Force cars models. And these are some of the automotive brackets, metal brackets, and you can see a lever arc that is produced directly with the metal. And now you can see 3D printed manufacturing tools, and here this is a template to remove or to unscrew or the tightening of the wheel to the wheel rib. Okay, so this is an application, and you can see here for locking. Hello, are you able to hear me?
Yes, sir.
Yeah. Okay, for locking, some device is also manufactured with the prototype rapid 3D printing only, and these are some of the lug nuts. Okay, Ford motors, and they are produced with the metal printers, and wind screen wipers also can be produced with the 3D printers, and these are some spare parts. And now you can see here this motorbike that complete all the parts are made from the 3D printed 3D printing only, and this is a German FDM 3D printer that have been used to print this motorbike. Okay, you can see here courtesy or credit, all the components of a big grape Nera motorcycle have been printed using 3D printing technology. And you can see here engine block. Okay, so 3D printed, and you can see this is not functional 3D printed a car. All the parts are printed using a 3D printing, and then it is assembled. Okay, so the name of this is produced by the Local Motors, and the name of the car is Sastri. Okay, and this is the extruded. You can see all those components. What are the components which you can able to see on the screen are all are produced from the 3D printing technique only. Okay, so this I will skip it, not required for you. So that's all about today's class. And if you have any doubts, you can ask me now.